polar molecule, and we have different in electronegativity. So it means that we have somewhere with more positive and somewhere with more negative. So we have electrostatic interaction. So we have interaction in our solid, and we have molecular solid. Or we may have ionic solid with iron, cation and anion. We have electrostatic interaction. Or we have the covalent bond between atoms, and we can get covalent bond solid. So we have the hydrogen. Okay. So in this we also call the. It's also easy, right? If you study, you can know what is it. And we have solid change to the liquid, and we have the melting or fusion, and liquid change to the solid without freezing. And we can write this equation, reversible process. So solid can change to liquid, liquid can change to solid. And we will consider about the first one. We talk about our step one. So total we have 4. Okay. So. Here you can see that we have the same initial state for our bowl at the surface of the liquid. But you can see that it depends on the liquid we use. So the bowl can fall down quicker or maybe slower. It depends on the viscosity. And viscosity depends on the temperature. So when you change the temperature, we can change the viscosity. Usually for the liquid, the higher temperature we have the lower viscosity. And for the gas, higher temperature, usually we have the higher viscosity. It depends on the interaction you have. But when you add some sodium, we dissolve some sodium into the solvent. So our vapor pressure can be reduced, and a new vapor pressure. The vapor pressure equal to the mole fraction times with the vapor pressure of the pure solvent. And then we can calculate for how much different when you dissolve some sodium into the solvent. Okay, so this one another property. Experiment, and you put 2 beakers in the flow chamber, and we have the same amount of the volume, but we have different concentration of the solution. It means that the vapor pressure of solvent from each beaker will be not the same. And then when we have this one with the higher concentration, so it means that less amount of solvent can vaporize. This one with the lower concentration, so we have more solvent can be vaporized. And then we have the balance. So after that, you can see that more solvent can be condensed in this beaker, and we can get the higher liquid level in this beaker. And at the end, we can see that the liquid level change. This one become higher, this one become lower, and the concentration will be balanced. How to identify what kind of the solid we have. That's what kind of problem we may have in your final exam. And also we consider about this one, and we focus more on covalent network solid. So here you can see that we have atom. And in this example, I show you about the carbon. But carbon, we may have that kind of structure or this kind of structure, and we have different electrons. So the first one, you can see that we have diamond, or we have silicon, or we have some other element, and they have that kind of structure. Really? So what is it? Yeah, we still need to use a long pen. Yeah, long pen. Do we have long pen? Do we have long pen? Yeah. 这个是这个阿嬷的产品，那个是那个
那个讲原子在哪里？ Give you all we can. Can we? Yeah, give it. Okay, can it? What is it?
Long pair.
Okay, and this one.
CL.
Okay, so can you explain the structure? Okay. So this should be the same color. This should be the same color. Okay.
This is something I show you. The low one here. So 4 atoms or 4 ions inside our cell. So it means that for this position, 4 ions will be inside of our cell. Okay. So we have different for the position, and you can see that the ratio always the same because you can see that for our chemical formula there, Z and S, the ratio 1:1. It means that 4Zn2 plus should be 4S2 minus in our structure. We have the H already. It means that they show you about the value for A already. So A equal to 408.6 BN. Okay. So they let you know the H already. So talk about the cubic cell. So this is our cubic cell. Okay. And the H, they should let you know the value from here to here already. Okay. This number. Okay.
To memorize the lowest and highest. Highest is tungsten, lowest is mercury.
Here we can see that they actually calculate the mass and they give you the density already. So you can see that silver in our cell, FCC, is that each corner we have and each face we also have, right? Okay, we have one more here, one more here. Okay. So now, how many atoms in one cell? This one is FCC. This means that you have 4 atoms in one cell. Okay. And now we calculate the mass of silver. So mass of silver will equal to, because we know that density equal to the mass over the volume. And you know A already. So it means that you can calculate the volume of our cell. Okay. So we have A. So it means that we calculate the volume of our cell equal to A cubic. Okay. So higher material. Or density of 1 cell, 2 cell, 3 cell should be the same, right? Okay. So density of silver, let's see the density of 1 cell as well. Okay. And we know that the density of silver equal to the mass of silver divided by the volume of silver. Okay. So the mass of silver here, so it means that the total number of silver you have 4 for silver. So you know the volume already, you know the density already, so it means that you can calculate the mass of silver in your cell. So principal quantum number n can be 1, can be 2, can be 3, can be 4, and so on. Similar with the one I draw here, right? So 1, 2, 3, 4. I may let you know the value n. I can say that at level n equal to 2 or at level n equal to 4. But in some type of problem, I give you already for the quiz, and I said that our electron at M shell or K shell. So you need to know the value of n for your calculation. Okay, our electron emit the light. So delta E can be positive or can be negative. It depends on the process, depends on the transition of our electron. Okay, so if I let you know Venus, I let you know the group, so it means that you know the element and you can write electron configuration. Or I can consider valence electron. So what is the valence electron? Outermost electron we have. So when you write down electron configuration, and you can see that the highest number n, and then we just calculate the total number of electron there, and we call that the valence electron. If you have S and P only, we just add them together, and that's what will be the valence electron. And the number of valence electrons is actually the group number. Okay. So some problem I showed you already, right? I said that our element maybe in the first Venus, so you know that the outermost quantum number n equal to 3. Okay. And I said that we have 3. So how many particles go in? The same number of particles go out. How many particles go out? The same number of particles go in again. And we call this one is dynamic equilibrium. Dynamic equilibrium is that the net change equal to 0. But we still have the changing. Example, in your bank account, you have 10,000 NTD. And I transfer 1,000 to you. You transfer 1,000 to another one. And I transfer 5,000 to you to transfer 5,000 to another one. So it means that the total amount in your bank account always 10,000. But we have the changing there, okay? But change to nowhere. So for B, I can reserve maybe 3 grams of the sodium A only. So for the 3 grams per 0.1 liter, or our solubility can be 30 grams per liter. Okay, so this is the common unit, gram per liter, the common unit. And on the level you can calculate the energy of your electron at that level, okay? And we can see that we have En equal to minus RH over N squared. So when you go out, it means that you have higher N. Higher N is means that you have the higher energy. When you go out, you have the higher energy, okay? The melting or fusion. And liquid change to the solid, we call freezing. And we can write this equation, reversible process. So solid can change to liquid, liquid can change to solid, and we have melting or freezing. And when you have the changing here, it means that we have the heat can be released or heat can be absorbed in our process. When you have ice and you want to change to liquid, it means that you need to provide some heat, and then our substance can absorb the heat, and the solid state can change to the liquid. And when you have the liquid, you want to change back to the solid, it means that you need to release the heat. So we have 2 reversible process. Solid we have, and we already talked about this one, you know already, right? So in some case we have atom only, and you know that the distribution of our electron can be anywhere around the nucleus. So you can try to practice with the learning check here. Okay, so you can scan this one, and we have around 15 minutes to finish the learning check with some simple problem. But I think it will be useful for you to check your study. If your study is already, so I believe you can solve the problem here easily. Okay. So that's the interface pattern.
Oh, this is
Yeah. Can you speak?
I should still use Pascal, right? If I want to use Google.
Yeah, but I mean, because we have many consultants.
Really? Yeah.
So what is the sure?
Hello, my name is Daisy. After this semester, I really think the way you teach is vivid and engaged. I think that is why I like your class. And also, you always put on smiles. And that makes you look like so friendly. And anytime I have a question, you will respond to me very quickly. So in addition, every time you go abroad, you brought us candies for us to eat, and you even hold some interesting activity for us to more understand what the chemistry is talking about, like the balloon. I think that's all. Thank you.
First of all, thank you so much for teaching me through this whole semester. And second, thank you for being patient, because I sometimes do mistakes and I always ask you at midnight. But anyway, I just want to say that your teaching is literally one of the best. For example, you give us like a presentation, and you give us like learning check, and you give us a previous quiz, and then you also give us like a solutions, like the practice, which have the without solution and with solution, and I always learn from that. It's really nice. And so even though I didn't really get good grades, I feel like I get the concept, so it's okay. Thank you.
Hello, I'm Blessing. I'm from Professor Tang's class. I think his class is really good. PBL really required me to think a lot, and his English PPT really helped me as a foreign student to study. Yeah, but as well, in this course, I just have a bad luck, so I keep doing a small mistake. Well, actually, I understand the topic, but yeah, Professor Tang, for you are doing a really good job in teaching chemistry.
Hello teacher, I just want to take a moment to thank you for your dedication this semester, and your teaching materials really helped me a lot on my chemistry learning. So I'm really appreciate for your teaching materials that really helped me to learn chemistry more deeply in English and in another way, in PBL method. So it's different with my high school learning. It's all new and very cool, and I enjoy the way I learn chemistry in university. So thank you, teacher.
Your English chemistry course take me a little bit time to adapt to the English version of chemistry. Also, I spend a lot of time for studying, but at the preliminary exam, gradually improve.
Teacher, so good. Very good.